Hello, yeah, in this video, I will cover several commonly used hypothesis tests for categorical data. They are the chi-square test for independence, the Fisher's exact test, the Mantel-Haenszel test, and the McNemar's test. Okay. So first is the chi-square test. The purpose of this test is to test whether two categorical variables are independent or associated. It is used to determine if the distribution of one variable is different across the levels of another variable. The null hypothesis, HO, is there is no association between the two categorical variables. In other words, the variables are independent of each other. For study design, this is for independent sample design. And type of data, you have two categorical variables with arbitrary dimensions. And that's their cross tabulation or contingency table can be of arbitrary dimension. So it's not just 2 by 2 table, you can have 3 by 4, 8 by 7, 12 by 10, things like that. Okay, so let's set seed for reproducibility, and we're going to use synthetic data set. So here we create a gender as male and female, preference like dislike, and then we create a data set. The total observations is 100. So we get the data frame, gender, and preference, and we can take a look at this data set. Got a two variable, gender and preference there. So in this data set we have two binary variables. Okay. And to form a contingency table, we can use the table command. Just put these two variables together into a table. If you take a look at the table, it looks like this. Okay. Okay. So then, for performing the chi-square test is very easy. Just chi-square.test of contingency table. Put into the chi-square test object. Print it out. You can see it gave you the name of the chi-square test that the test performed, and tells you it's a test with a yes, a continuity correction. So this correction is made to improve the approximation used in this test. Okay. And then it gives you the chi-square test, the degree of freedom, and the p-value. Okay. Okay, the next one is the Fisher's exact. And the purpose of the Fisher's exact test is to determine whether there is a significant association between two categorical variables in a contingency table. And particularly when sample sizes are small or when the expected frequencies in the table are low. So basically the Fisher's exact test is used when the chi-square test fails. Okay, if you have small sample size or low expect cell counts, the chi-square test will not be accurate. So you're going to use the Fisher's exact test. And the mechanism for this test is it calculates the exact probability of observing the data under the assumption of no association rather than applying on the approximation as in the chi-square test. So this test is really using the exact values. So it is accurate, but it's computationally intensive. And the null hypothesis is there's no association between the two categorical variables. And study design is still independent study design, and type of data is only works for 2 by 2 tables. Okay, so we can create the same data frame, but now we only have sample size of 10. Okay, put together the data frame, look like that, and then contingency table, look like that. You can see the cell counts are really small. And to apply Fisher's test, you use Fisher.test and put the condensed table object in there. It will perform Fisher's test and then give you the output down there. Tells you the p-value and the alternative hypothesis. And it also gives you a estimate for the odds ratio and a 95% confidence interval for the odds ratio. Okay. I just want to show you what happens if you use the chi-square test on this small sample size data set. So you can see it gives you the warning message telling you this chi-square approximation may be incorrect. Okay. Okay, the next one is the Mantel-Haenszel test. This is a more sophisticated test. The purpose of the Mantel-Haenszel test is to assess whether there is an association between categorical variables after adjusting for or controlling for a third categorical variable, and typically a stratifying variable. Okay. So the null hypothesis is after adjusting for the stratifying variable, there is no association between the two mean categorical variables, for example, exposure and outcome. In other words, the odds ratio for risk or risk ratio is equal to 1 in all strata, meaning there's no consistent association between the variables across different groups. Okay. Study design is a stratified independent sample design. And type of data, you get 2 by 2 by k. So basically it's a sequence of 2 by 2 tables. And the Mantel-Haenszel test is really important for assessing confounding in health studies. Okay. All right, so we can set the seed, and now we can define 3 variables: exposure, which is exposed versus not exposed; outcome, disease versus not diseased; stratum, say young and old, so we're stratifying on age. We create a synthetic data set. Number of observations per stratum would be 50, and we put them together. The data frame is exposure, which is sampling from exposure, size equal to 2 times n. Replacement equal to true. Outcome, sample from the outcome variable, size equal to 2 times n. Replace equal to true. Stratum is repeat the stratum, each equal to n, and then. Okay, now here's the data structure for the synthetic data set in order to perform a Mantel-Haenszel test. So if you have a real data set with many variables, but you must have 3 variables like this in order to perform the Mantel-Haenszel test. So we can put together the condensed table, and then we can use the old table. We put the table young and table old. We stratify, into young and old based on the stratum variable. Okay, so let's print out the young table and then print out the old table. Okay, and for each table you can get a odds ratio estimate. So now we need to perform the test in order to decide whether these 2 variables, exposure and outcome, are associated after adjusting for the stratum variable. So one thing you can do is to use the array command to put together the table young, table old, and it's a 2 by 2 by 2. Okay, and once you created the array, you can feed that into the Mantel-Haenszel test function, and you can print it out. Okay, all right, and then the last one is the McNemar's test. The purpose of McNemar's test is to analyze paired nominal data to determine whether there's a significant change or difference between 2 related categorical variables. Related means they're dependent. Okay, so null hypothesis is the proportions of discordant pairs are equal, meaning there's no significant difference between the 2 related categorical variables. Study design, you must have pair design, and type of data, the binary. Okay, so here let's define yes or no. That's the response. Number of observation 50. We put together before and after, and this is the data set look like. Okay, so this is before after they are matched. The data come up in pairs, and then we can use the table to put together a condensed table. We can print it out. It looks like that. And then for performing the McNemar's test, just use the McNemar dot test and put the condensed table object in there, and then print out the result. It tells you the chi-square test, the degree of freedom, and the p-value. Okay. All right. So this is a demonstration of the 4 commonly used hypothesis tests related to categorical data, and hope this helps. Thank you.